All right, we are going to get started. It is 10 a.m. on the dot. I'm sure some more people will join, but since we have a limited amount of time together, I want to make sure that we have as much time as possible to talk to Juan and Joe. So hi everyone, my name is Kathleen Hunt and I am a community manager here at Udacity. I haven't had a chance to get to know all of you, but I have had a chance to talk to some of you, so it's great to see so many familiar faces here. I am joined today by Joe and Juan, who work on the Facebook AI and research teams in Menlo Park, California. Joe and Juan are going to be sharing some insights today about their roles at Facebook and the types of projects that they work on. And thank you so much for being here today. We got a ton of questions, so really excited to hear your insights and what you can share with this community. And thank you to everyone who filled out the form and submitted questions ahead of time. We got literally hundreds of questions from you all. So while we won't be able to answer every single one today, Joe and Juan will do their best to get through as many as possible. So without further delay, I want to give Joe and Juan a chance to share more about themselves. And maybe you could both start out just by sharing a little bit about your career path that got you to the field you're in currently, and then talk a bit about your day-to-day role at Facebook. And I need to unmute you, so give me one moment to do that.
Hey, everyone.
Perfect.
Hello. You want to start, Juan?
Sure. Okay, so first of all, I'm really grateful for this invitation for this webinar. So my name is Juan, and I'm a research scientist in the language and translation technology team. So I'm currently working on machine translation. So you're probably familiar with what that means, but just in case, machine translation means that you automatically translate from one natural language like Spanish to another language like English. So on Facebook, one of the main applications is the C translation feature. So when you browse Facebook and you come up with a post that in a language you don't understand, we'll provide you a link, and then you can click and get an automatic translation. But of course, there are many more use cases. So in terms of background and career path, so my background is actually in math, physics, and computer science. So I did my undergrad in Paris. At the time, I didn't know anything about natural language processing or machine translation, but I knew I wanted to combine somehow science and linguistics. And so I found out about this field, and I went on to do my master's at CMU, but at the time I didn't work on machine translation. I first studied, so I took classes on NLP, of course, and my research project was on computer-assisted language learning. So later on, I was really passionate about translation, so I moved back to Europe for my PhD, where I studied machine translation at Cambridge. And Facebook is actually my first job. So I started in August 2014. And initially I was in the London office, but I was, the translation team was here in Menlo Park, but I was so passionate about my field that I decided to work remotely. I worked very late with 8-hour time difference. But after 1 year, I was able to move here, and I'm still working here on machine translation. Kathleen, do you have any specific questions I need to answer for this introduction?
No, that was perfect. And Joe, I just unmuted you. Sorry about that.
Yeah, sorry. I didn't want to destructively interfere with Juan, so I muted myself. So hopefully I'm unmuted now. Joe Spizak. So I'm a product manager at Facebook. So my main product is PyTorch, but I tend to look after kind of our AI open source platforms. So things like Onyx, if anyone's familiar with Open Neural Network Exchange, that's something that I continue to drive and work on alongside Microsoft and Amazon. And then I tend to be the guy to support and work with other teams across Facebook as they open source projects, specifically AI ML related. So if you've seen some of the recent things we've open sourced, like PyText, which was the NLP framework built on PyTorch. Also Horizon, which was a large scale reinforcement learning project also built on PyTorch. You're gathering a theme here. So I tend to be the center orbit of a lot of different projects, but with my main product management focus is really PyTorch. And so what that concretely means is looking at PyTorch as a project that is literally used by hundreds to even thousands of people inside of Facebook for anything from research. Folks like Juan, who's doing his translation research and trying to scale that into production. Also, the FAIR researchers. We have hundreds of researchers that are using PyTorch as kind of the basis and really framework, for work in computer vision, reinforcement learning, robotics. The list kind of goes on and on. And then our team also works significantly externally. So we work with partners like Amazon and Microsoft and Google as well, and cultivating an open source community and a research community. And really my focus over the last year has really been building PyTorch into not only a research platform, but something that takes research and exploration into production scale. And then working externally to start to see usage occur in production. So some of our partners there are like Tesla, Uber, Salesforce, Airbnb, lots of companies that are using PyTorch, within their research and looking to take that into scale. And we actually run at quite a large scale, in hundreds of trillions of predictions a day. And I think Juan runs it, the billions of translations a day. So we have a lot of experience in running these large scale systems. And so it's really cool that we're able to share that broadly externally. My background is, I started out my career as a double E. So I was electrical engineering undergrad. I was a chip designer out of school. So I was basically developing ASICs and systems on chip for phones, and working for Motorola at the time. So Motorola is not as big of a company as it was back in the day when I started. And I spent most of my career actually in video, anywhere from mobile video to broadcast video. About 6 or 7 years ago, I found deep learning. I thought it was really cool. I met a gentleman named Yanqing Jia over at UC Berkeley when he was a grad student before he open sourced Cafe. If anyone's familiar with Cafe, Yanqing was the author of that project. And I fell in love with it. I thought it was really cool. Started hacking on it, playing with it. It was really early days for deep learning, and there were only a few projects like Cafe and Torch and Theano over out of Montreal. And just kind of fell in love with it, started playing with it, hacking on it. I had a team at the time I joined Intel, and we started doing computer vision and augmented reality with deep learning on the edge, on edge devices. And basically from, since then on, I've been working on kind of, what we're calling AI now, but really machine learning and deep learning. Working for Intel, and then Amazon next, prior to Facebook. And then for the last year here, I've been at Facebook as a product manager. So I definitely have not, I don't come from the roots of Juan, doing a PhD and being a researcher. I come from kind of a diverse background, kind of diving deep into video, diving deep into hardware and technology, and then like the last just really 6-7 years being self-taught, and then kind of rising through different companies and learning and exploring along the way. So it's a very non-traditional career path.
Thank you both so much. And I think kind of before we have some really specific questions that came through, but at a high level, it would be great to hear from both of you, how is working in the industry different from academia and kind of the learning side of things? And what recommendations would you have for people who are still maybe on the more academic side to overcome those differences to prepare for a more practical application?
Yep, why don't you go for it, Juan? I think you have a pretty good view here.
Sure. Yeah, so I would call out that one of the main differences in the deep learning field is that we have way more GPUs than academic labs. But apart from this trivia fact, I think some differences include maybe more teamwork. So if you're a PhD student in academia, you tend to work on your own projects. Sometimes you have a little bit of collaboration with other postdocs or PhD students, but mostly it's your own project, your own thesis. Whereas here we emphasize a lot of teamwork. You need to work with your colleagues in your direct team, but sometimes you also need to reach out for help in other teams or other offices across the ocean, etc. So teamwork is very, very important. And it's also tightly coupled with better engineering practices. So because we tend to work in teams, it's very important to write code that other can reuse or at least understand that, or that they can like take and run on their own. So I would say that all these differences are quite important. In terms of knowledge itself, I think we actually we are eager to hire a lot of the PhD students and master students from and undergrad students actually from universities, because we know they have like the relevant knowledge. So actual theoretical knowledge of the field is not a problem. I would say that a little bit of practical knowledge is maybe where the gap is. And in terms of recommendation, I would encourage folks to take as many internships as possible. So that was one of the other questions. What would you do better if you started your studies all over again? And so I studied in Europe, where the trend is to not do internships as opposed to the US. And I think this is a really great opportunity that undergrad and graduate students have here to, you know, go to an academic lab or a company every summer. This is really, really tremendous learning opportunity. So I would really recommend to do that.
Yeah, I mean, to follow on that, I think so just as a premise, I think, you know, companies like Facebook, the scale we run at, and then kind of the diversity of the problems we're trying to solve, we can't consume the bleeding edge research fast enough. I mean, there's like, we see potential in things like, you know, this is kind of somewhat related to what, you know, Juan does in translation, but things like quantization or low precision deep learning, like these are areas of active research. People are actively trying to find out, you know, where that bottom of precision is, and how to approach it. And even over like the last year or two here, we've seen, you know, things like pruning and you know, kind of 8-bit integer, and even these kind of binary nets and all these, this area of active, like we can't consume that fast enough, because it's actually a huge benefit to our business and allows us to just you know, generally for a better developer experience or better user experience for things like Oculus on, you know, headsets where we have a lot of power constraints. So I would say, yeah, to follow on, you know, Juan's perspective, like getting, you know, if you're a researcher in academia and you're in one of these areas where, you know, you're trying to solve, or you're trying to, you know, really push the state of the art in certain areas, it's really nice to be able to join an industry, especially someone as diverse like Facebook, where, you know, there is going to be a team that's kind of trying to consume that kind of research and put it into some kind of production scale, whether it's on an edge device or whether it's as part of translation, where like Juan runs, you know, quantized inference for translation, because frankly, it's just, you know, it allows them to scale up more efficiently on CPUs and just generate better performance. So there's just a way for us to consume all this, and so really marrying that research background with, you know, the production mindset, or like the industry mindset and production scale, is really, really valuable. From a product manager perspective, my advice is a little bit different. You know, coming from the academia world and just coming out of school, it's hard to be a product manager in industry right away, whether it's, you know, I've been a product manager and managed product teams at Amazon and, you know, now at Facebook. And I think like the key that I look for there is actually more domain knowledge, and frankly, a bias for action, or a you know, a driver mentality, someone who can move an ecosystem or move an organization. But really, you know, have the background to be able to have conversations with gentlemen like Juan in the space. So for example, the PM on NLP, you know, Chris over here, has a really strong background in that space. So someone who's a researcher in that field and just is someone who's super cross-functional, is collaborative, is able to really think clearly about how to define problem statements and then measure success. You know, from a product perspective, that's kind of what we look for more. Hopefully that helped.
Thank you both so much. And kind of building on that on an ongoing basis, what do both of you do to keep up with the changes in the field of AI? How do you constantly improve your skills? What recommendations do you have around that?
Okay, so I'll start again. So first of all, I should point out that this is actually really difficult, especially so. Keeping up with, you know, new publications and things like that is something that depends on the field. But in the case of deep learning and machine translation in particular, it is actually very difficult, because it's especially since the last 3-4 years, it's a very, very fast moving field. So it is a challenge. So I would say one advice I have is to read as many papers as you can. You can download Archive Sanity or use Google Scholar recommendations and have a schedule for reading papers on a regular basis. We internally organize reading groups, so that's very helpful. Even if you don't have time to read a paper, maybe someone else will present a paper and we'll have an idea of what's going on there. And I think the killer feature that we have here is that we can go to conferences maybe at least once per year. So this is really important. By going to conferences on a regular basis, you get a refresher on the trends, new things, and you come back with like a bunch of ideas, and you're super excited about how things are moving forward. Yeah, so reading papers, so there's no secret sauce. Basically, you have to like sit down and read, and you have to attend conferences, discuss, talk to people, and yeah, and come back and then apply all these learnings to your own work.
Yeah, I mean, similar advice. I definitely think attending, at least, one or two like the leading edge research conferences is beneficial, and just really immersing yourself. So in RIPS, ICML, you will definitely learn a lot. You'll build contacts. Follow certain folks on Twitter, and AI kind of revolves around Twitter for whatever reason. So there's definitely a lot of folks out there that you can, like Andre Karpathy is a great guy to follow. Jan LeCun from our side is a great guy to follow, who, they're always, they're in the center of the state of the art. So you kind of have an idea of kind of where things are going, where things are trending. So following kind of the thought leaders in the space, and they all kind of have their own perspectives. Like Jeremy Howard is really interesting to follow. He's not a traditionally, a cutting edge researcher, but he applies cutting edge techniques in his classes in Fast.ai. And so if you follow Fast.ai, he'll consume, like he is maniacal about bringing in the cutting edge and the latest and greatest algorithmic approaches into his libraries, into his classes. So following him and Rachel Thomas also is super beneficial. So those are, I mean, along with reading papers and definitely, attending some of the conferences. So there's definitely not, I would say not all conferences are like built the same. There's kind of the industry, kind of the O'Reillys where, you might get, there might be some lag in what's presented. So if you truly want to be on the bleeding edge, you want to be like at the, ICLR, ICML, NRIPS, CVPR class conferences. The rest of them will tend to be, more lagging in like applied ML, where it's, there is a lag on the cutting edge of what comes out of the academic and research lab perspective and how that gets operationalized in production. So, that's getting faster and faster. That's, I should say, shrinking that lag, but there's still a lag there. And so cutting edge is definitely in those academic centric conferences. And then probably the state of the art of what's applied in production tends to be in these other kind of conferences like, AI Conf and others, ML Conf.
Just to follow up on following people, you can actually follow people on Facebook as well. I have a few prominent researchers like Jan LeCun and Andrew Ng at the top of my newsfeed. And I wanted to point out that there are also some very interesting blogs, especially on NLP. I can definitely recommend one, which is called router.io. And sometimes these folks, they actually go to conference and do hard work for you, and they provide you a summary of what's the new trend, what's important.
Yeah, one quick follow into one. The other way to stay, I would say, kind of on the bleeding edge, is to follow the classes that kind of I would say the leading edge academic institutions are doing open classware around. So Stanford just announced their NLP class, which is all based on PyTorch, which is awesome. And that is, Stanford NLP is probably one of the best programs in the world. Same with Berkeley Computer Vision. So Alyosha and Jitendra Malik, who Jitendra's over here in Fair Menlo Park, they have open classware. Like their class starting here, I think actually today or yesterday, actually is it's all based on PyTorch. All the classware is going to be open and available, all the videos and all the lessons and everything. And those guys, I mean, that's kind of the ground zero in a lot of ways for like NLP and computer vision. So finding those like universities that are doing open classware and just taking those classes like on your own or consuming what they produce is a great way to kind of stay on the bleeding edge as well.
You both just shared a lot of amazing resources. Would it be all right if I follow up with you to get a list that I can share out with students afterwards?
For sure.
Perfect. That would be great. I will, everyone tuning in who is furiously trying to write everything down, will make sure that we get a list of recommendations of speakers and blogs and universities and things for you to check out for further learning. Wonderful. So speaking about kind of the cutting edge of research right now in the field, what do you think is the most interesting and fast moving area of research in the field right now?
Okay, sure. So I can probably speak for NLP because this is my domain. For a broader view, maybe you have to do your own research or rely on Joe. So in terms of NLP, I think big trends right now are moving towards more unsupervised or weakly supervised techniques, which means that we rely on less and less training data. Probably another important trend is building models that are robust. So this trend actually started in computer vision, but is slowly starting to build up momentum in the NLP community as well. So building models that are robust means that they won't make mistakes when you feed them with like unusual input, like that contains typos or slang, or feeding input that is on purpose malicious to try to avoid, you know, some kind of classifier or things like that. In terms of maybe in a more general trend is actually moving towards ethics and fairness and trying to understand models better and see how we can overcome biases that are present in the data. How it's also another form of robustness, actually, but more on the training side. Yeah, and so all these challenges that are relevant for the NLP and AI community, they also apply internally. So for us, it's very important to move towards techniques that rely on less data. Just to take the example of machine translation, we don't want to only serve translation systems that, you know, translate between Spanish and English. We have tons of resources for that, but we also want to like serve all languages in the world eventually, and we do not have like the labeled data. We can buy some of this, but you know, it doesn't scale. So we have to leverage these new techniques. And something that is very, very relevant for our internal use cases, all the research that applies to making models fast. So you can tackle this problem maybe from different angles. You can tackle this from the modeling perspective, and there are things like that you can do, like just, you know, dumb hyperparameter tuning, but also more advanced techniques like knowledge distillation. You can tackle this at the framework level by building custom quantized operators that Joe mentioned before, or you can like even go all the way to hardware level. So I would say this is a very brief and certainly incomplete summary of challenges and trends.
Yeah, to follow on, definitely echoing some of Juan's points, but I see, and not so much just from a pure research perspective, but just generally when you look at the vertical and horizontal, you know, stacks and workflows respectively. So, I mean, vertically, Juan touched on a few things. Like we see vertical. If you look at all the way from the hardware level, even the fleet and hardware kind of ASIC level, there's obviously trends. There's a number of startups. You know, we're building hardware. Amazon's building hardware. They announced. Google obviously has had their TPUs for a number of years. So there's innovation happening all the way at that kind of intrinsic hardware ASIC level. But there's also, you know, to Juan's point, there's libraries that are being built. You know, quantized kernel libraries. To take advantage of that. There's also compilers. There's a huge trend right now in compilers are all of a sudden sexy again, which is interesting. So we have our own called Glow it's called graph lowering. So basically taking a graph that would maybe be an input from someone like Juan as a researcher. They want to lower that onto you know, some kind of hardware and actually generate super optimized code for that hardware. And so that's a massive trend. Google has XLA. We're working with them on TPU integration with PyTorch, so you can train and deploy on TPUs with PyTorch as your authoring API. But then as you move up that, you know, stack, it's like every layer is, you know, there's ways that you can kind of optimize things from the model architectures, like structure, like you know, kind of model architectural search. That's, you know, can be done at the framework level. And then when you kind of look horizontally at that workflow, Juan talked about data and data annotation, and that's a huge limiting factor because supervised learning is expensive. Like even for a company like us that runs at the scale we do, supervised learning, it takes time, and annotating data is not cheap. And so gathering these types of data sets does take a lot of effort. So things like semi-supervised or even unsupervised learning becomes really, really attractive. So we tend to focus our research there. But then there's just the general trend horizontally of, what in Amazon we call kind of that undifferentiated heavy lifting of someone's workflow. So all of those things like, loading data or annotating data or distributed training or deployment of a model or hyperparameter tuning, all these towards a commodity type level where, your workflow really becomes problem centric, meaning that I don't have to worry about doing, for example, random grid search because something's going to do that for me, or hopefully something smarter, like maybe some Bayesian strategy. But like deploying a model and creating a RESTful API shouldn't be something that I have to go learn a new tool for. It's one line of code or some Python SDK like an Amazon SageMaker or something else. So very quickly we're seeing kind of the commoditization of the undifferentiated pieces of the workflow, and really the ability for anyone, whether they're an applied researcher or otherwise, at focusing on the problem that they're trying to solve. So that's the other general trend I've seen. That's really a multi-year problem. When I first started in the space, I saw startups that were like, they were differentiating themselves on distributed training, and distributed training today is very much a commodity. Like these days it's one line of code in Amazon's platform where I choose the number of instances and it actually will orchestrate the containers underneath. I don't have to learn Kubernetes. Kubernetes is a great project. You should learn it anyway, but you don't really have to know it because actually they've taken care of that for you. So you can actually apply your effort and your knowledge on the problem. So that's the other trend.
Great, thank you both so much. Juan, you touched on something earlier that kind of relates to a question that was asked ahead of time. You mentioned the trends happening in ethics and bias in AI and things like that. And somebody asked that about accuracy of AI systems and how you manage those types of errors. And I'd love to kind of hear you expand on errors in AI systems, and also maybe more human errors, such as putting bias into AI systems as well.
Sure. So in terms of how to handle errors, so first of all, our AI systems do produce a lot of errors, and we are aware of that, and I'm sure people on our platforms are also aware of it. So there are several ways to deal with that. So I guess the first answer is at the product level. So, when you see a product feature on Facebook or other family of apps that Facebook owns, if you see something that was produced by AI, and if you have a message, oh, this was automatic, or this was an automatic recommendation or an automatic translation, then you are aware of that this is an AI system. So you have kind of a warning, and then hopefully you will lower your expectations. Although there's always like a big gap in between practitioners' expectations and public's expectations, which is the public expects like perfect AI systems, whereas we know, we work with these AI systems, we know their weaknesses, so our expectations are lower usually than the public, and this discrepancy is actually causing problems. So the first answer is at the product level. The second answer is that we do test our systems, and when we train them, we actually benchmark them, and we know offline results. And we make sure that when we deploy something to production, it has to be better than the previous version, and we do extensive testing for that. And then another solution is that if you see a mistake while your system is running in production online, and someone reports it, like an employee or a bug report from an external bug report or internal bug report. So we have actually mechanisms to very quickly fix things. So when we build AI systems, it's actually also very important to build safety around, can you fix something quickly if a relatively bad error happens? So all these mechanisms are quite important. In terms of ethics and bias in AI, this is actually an active area of research, and we are, striving towards incorporating that research into our products and services.
Great, thank you so much. Joe, did you have anything that you wanted to add on?
Nope, Juan covered it nicely.
Great. So talking more about the work that you do at Facebook specifically, how does your day-to-day work become applied within Facebook products or even beyond Facebook products?
Okay, so I'll start again. So how is our research applied to Facebook products or even outside? So we have various ways. So in my particular case, what happens is that the research and the development we do is tightly coupled with a service that serves translations in my case, but it can be anything. And so this means that when you show some kind of improvement, all you have to do is redeploy that system. So essentially, the transition from your research work, your development work to production is actually quite seamless, quite fast. And then what happens when you actually redeploy, a new system or a new model that is better than the previous version, it actually affects many products, because the service serves, the C translation feature I talked about before, but also anybody that uses translation. We have translation available now on Instagram or Messenger. So all these products are affected. So sometimes we also have longer term projects. So for this, the lag between the research you do and when it goes live into a product or a service is longer, but eventually we'll find it should hopefully find its way there. Sometimes the horizon can be 1 year or even 2 years sometimes. In terms of how do we have impact outside Facebook, how do our research goes outside Facebook? I would say that the simple answer is open source. So Facebook is very encourages us actually to open source our code as much as possible. You can check out the github.com Facebook research organization. It's a GitHub organization which has many projects there. You can check the PyTorch organization, and I think there are a few, there's a Facebook organization. So if you check all these GitHub organizations, you can see that we do not shy away from open source our code. And some of these projects are actually tremendously successful. I think the most successful project is actually React. It's the top Facebook project, and it's one of the top open source projects in the world as well.
Yes, as far as my perspective, so PyTorch is kind of the beating heart of our internal workflow. So for researchers and production kind of research engineers looking to take what we're doing into actual production scale, frankly, like folks like Juan and his team. And so we basically, PyTorch becomes the center of it, where and it's kind of wrapped in a number of services. So there's an authoring workflow, called EpiLearner, which allows you to distribute the training. There's a number of kind of data services or data stores that front end that, so I can basically grab data from Hive, for example, or Manifold, which is kind of akin to something like an Amazon S3 that we have a high available storage. And then we have a service that kind of wraps the production inference. We call it Predictor internally, but it's very centric to how do I create an endpoint that then gets consumed by an application to do predictions within that application. So PyTorch becomes that really that research authoring API that allows different teams to quickly explore different spaces, iterate on their ideas. And then within the tooling that we have at Facebook, be able to scale that into production very quickly. Externally, our impact, again, like echoing Juan, is open source and really, the research community. So, in a lot of ways, we're motivated from a PyTorch perspective to stay on the cutting edge of research. So we're lucky that we have a great community. We get a lot of the research out there on PyTorch, from the beginning. When something comes out, that's brand new, transformers, whatever it is, it's on PyTorch from the beginning. That allows us to easily consume it internally at Facebook, evaluate it, start to explore, is this an area that we want to invest in that looks promising from a product perspective. And so, yeah, our impact is open source. It's staying on the cutting edge because we're not, we don't have all of the good ideas, right? We have a great team, but there's just a massive amount of really amazing research that's happening out there. And being able to work, number one, collaboratively with those researchers, and number two, be able to pull their ideas into Facebook, for us to easily consume, allows us to really, as a company, also stay on the cutting edge.
Great, thank you both so much. What would you say is the coolest or the most exciting thing that each of you have personally ever worked on, either at Facebook or elsewhere in your careers?
Sure. So in my case, the most exciting project was to start actually the transition from traditional phrase-based machine translation to deep learning-based machine translation back in January 2016. So we started as a team of just 3 people, and we decided, okay, there's this new technique, we should really investigate it. And we spent around 6 months to build our first system, and it was available. We were planning, actually the backstory is that we were planning to work on English and Spanish, but turned out that this technique was better for English and German. So we ended up working with English and German because English and German have more reordering between the words. And then from there, we expanded the effort to move more and more systems. And we ended up in June 17 by transitioning entirely to this new paradigm, and that gave great improvements. And then we were really excited about this. And the reason it was probably our most successful, my most successful project was because we were the first in the industry to achieve this transition. So, and also the reason I really like this project is because it started out as a bottom-up initiative from just 3 folks starting out a small effort, and it built up. It slowly, gradually built up into a more important initiative.
So from my perspective, I think the thing that I'm most passionate about, and I have been in my career, is building ecosystems. And I mean, I'm kind of lucky that I'm working on probably the most exciting project I've worked on, I think, in my career. I'd probably second to Onyx and building an ecosystem around Onyx and having such an amazing, I'd say, industry ecosystem around that project. But like for me, I kind of knew Facebook well. I've known the researchers and the team, for a number of years here, and so I've actually been wanting to work on this project for a long time, and kind of had a vision even outside of Facebook, that I brought in the last year, or when I came in January last year. And so for me, like being at the center of such a cutting edge field and being like really the person to really own the vision and the platform and the language that research is created in is kind of exciting. It's I mean, you're kind of ground zero for the cutting edge of the space. So for me, working on PyTorch is kind of a dream job, and this team is amazing. It's a partnership with FAIR, with Facebook AI Research, and also the AML team, applied machine learning team that Juan is part of, and then also our AI infra. So for me, like I have an ecosystem internally, but I also get to work externally, in a significant manner with the open source community, with the research community. I get to, like, for example, work with CERN on, we're working with them on the particle ML challenge. Like it's kind of the sky's the limit on who I can collaborate with and who I can engage with. And just seeing the diversity of perspectives and seeing this community grow, and this, I mean, just this Udacity class, is representative of that. Like just the sheer number of people and the geographic diversity of folks taking this class and doing meetups. Like, I mean, this is what motivates me and gets me passionate. So, so I'm lucky. I'm working on my most exciting project.
That's pretty great. It's always amazing hearing people who are able to take something that they're passionate about and actually make it into a career. So it's wonderful. What do you both see as the future developments of PyTorch, and how will it continue to impact the deep learning community?
Sure, I'll take this one. So I think, over the last year, PyTorch has really changed it. So when I came in, it was very much an authoring API that was very research centric. We couldn't serve Python models really in production, maybe with a few exceptions. We built Onyx, and Onyx was a kind of this common format that we could do and use to export. And actually, Juan's been using that and has shipped, I don't know, probably hundreds of models for translation using that. But looking at by extension a way to really build more efficiency in it and how to take exploration into production very quickly is what PyTorch 1 that vision was, and seeing that get released at NRIPS this past year was amazing. So we kind of have this common research to production platform that we have a foundation of now. Where we build from there is to look at things like mobile. Like mobile is another one where we'll invest in this year. And the nice thing is we have assets like Cafe 2, where you have a runtime that is on, I think I checked the numbers just earlier this week, and a Cafe 2 running deep neural nets is shipping on over like 1.2 billion phones. So whether it's iOS or Android phones, it's a few hundred kilobytes type runtime size. So it's pretty tiny. It's super fast. With the portal devices, we're doing essentially mask RCNN and these really complex, instance segmentation type models on those devices in real time in very low power devices. Oculus is using this framework. So we're for very low power type things like hand tracking in their new devices. So like Edge and mobile is actually probably a next wave of things we're going to invest in on the PyTorch side of things, where you'll be able to author, say some type of model. It might be translation. Actually, it might be NLP, likely computer vision, and be able to quantize, prune that model, be able to take that into some type of efficient state and deploy that really, really easily onto an edge device. Part of this also is because we have partners like Tesla and Uber who are trying to use this platform and ship those onto autonomous vehicles. So we have partners that are giving us requirements and saying, basically we have this class of workloads. We have this end type platform that we want to target, but we're all in on PyTorch. We're authoring a lot of our research using it. Now, how do we get this efficiently running when you have all these sensors, cameras, radar, et cetera, that are on the edge device? So I see that as kind of a big effort from our perspective. I would say the other thing you're going to probably see is it's just going to get easier to scale PyTorch in production. So with a diversity of devices, so we continue to work with Google on TPUs, and we'll see them start to ship that later this year into production GCP, where you can train and do inference, with TPUs using PyTorch. So it'll be just more efficient, easier to use. It'll be well integrated into cloud platforms. And so we expect basically PyTorch to be a platform from really research all the way to production for a good portion of the folks out there, a lot of companies as they transition. Because frankly, the user experience of PyTorch, as you guys have figured out, is really clean. The code is super readable. The API it's a very there's really only one way to do things on PyTorch, and it's a really good way to do things. It's very Pythonic, and so I think that's it's really popular. The last thing I'll mention is the other areas we plan to invest in are APIs, like domain APIs. So if you're familiar with the Torch Vision API, there's going to be some investments on like Torch Text and Torch Audio, and really taking out kind of that undifferentiated heavy lifting that an NLP researcher has to deal with. So, for example, tokenization, of data, of text, is something that every NLP researcher has to deal with. So, adding that as an API, a la data transformations in computer vision. So, if you look at the Torch Vision API, there's, basically a number of transforms that you do. You can flip, warp, etc., augment your data. So we want to have a set of nice functions, data sets, models that are on the state of the art, for each of these domains to kind of accelerate the research community. And then we also plan to invest in kind of the other end of the spectrum. So for hackers, for application developers, how do you take, basic building blocks and put them together, within the PyTorch ecosystem in Python, 50 lines of code and build an application that takes a number of kind of intrinsic building blocks, puts them together, and allows you to really scale into a fun application. We're inspired by Jeremy Howard and Fast AI, and we'll probably work with him on that. But really, how do we make that something that anyone, not only folks like yourself who are taking the time to learn PyTorch, but also the folks like my daughter, when she's a few years older, maybe she can just pick up PyTorch, write a little bit of Python, and actually create a really cool application. So that's the future that I see.
Wonderful. I'm going to ask one more pre-submitted question, and then I do want to leave a few minutes for some live questions because some great ones have come in the chat since we started. So kind of to wrap things up, and it's kind of two questions in one, but for people who are maybe struggling with imposter syndrome or a lack of confidence entering the field, what advice would you give to somebody who feels that way? And what other advice would you give to your past self? If you could look back on yourself when you first started your career, what would you tell yourself then that you think other people could benefit from hearing, given where you are now?
Yeah,
sure.
Jump in one.
Okay, so I should point out that first of all, I do have imposter syndrome almost every day, so no worries there. A lot of people have it, so it's actually very common. So I would say that I would say just do your. It's all about the work and progress. So just focus on the work, and one important thing when you're in school, it's all about learning, but when you're at work, you have to deliver results. So you have to carve out some time for self-development. So that's also very important to, keep learning on the job. So yeah, it goes back to the previous discussion about, reading papers and going to conferences and things like that. In terms of what advice I would give myself, I think I mentioned that earlier, but more internships is something that's critical for acquiring like practical experience. Maybe another advice is to really, really focus on the fundamentals. So this is something that's like culturally dependent, but some cultures shy away more from math, and some other are more keen on learning more math. So I think the strong foundations in math and computer science algorithms are very important to drill down and really get them like sealed in your brain for a very sustainable career path. So yeah, Joe, you can go for it.
Yeah, I think it's funny. Imposter syndrome is not unique to anyone in the space. I think everyone sees how fast it moves and like, man, this is incredible. Like, I'm surrounded by some of the brightest and amazing people on the planet. So my advice, first of all, is to, definitely keep a path of personal growth. But the best way to grow though is to actually do. So I found that when I started in the space, like I started watching videos, and I watched like Nando de Freitas' class at Oxford, and and just like passively started watching videos. I was like, okay, this is interesting, and I learned a lot. And then when I really started to learn is when I started actually doing like the coding exercises, and that was great. And I started to learn kind of these algorithms at their fundamental levels as I'm actually trying to code them. And with Andrew Ng's class, if you take his online class at Stanford, or his deep learning.ai classes, like he takes you through the fundamentals and makes you code in NumPy, like stochastic gradient descent. And same with like him and Rachel just wrote a tutorial for PyTorch. So if you go, it's a brand new tutorial. We haven't even really promoted it all, but it's on Torch NN module, and kind of takes you from kind of NumPy refactor, and shows you how to use it, Torch module, and so basically kind of more and more abstraction. But it's really nice to understand kind of the fundamentals and kind of the underlying, the nitty gritty of things before you start to jump into a lot of abstractions. But the real part of when you start to master things is when you start to generalize. So it's fine to start, looking at kind of tutorials and hitting Shift Enter on Jupyter notebooks and all that. But when you start to actually like take the tutorial itself, or take the algorithm, and you start to generalize it, or you start to hack together your own data set, that's when you really start to learn things. And that's the advice. Like I've been advising the curriculum for Udacity for AI for I think now a year and a half, or almost 2 years now, I guess. And that's like the single feedback I always give to Matt and to the guys is you want the students to really like kind of learn the fundamental through the lesson, but you really start to grasp the concepts when you start to apply them to other problems, and you really start to have to improvise as a developer once you've kind of learned the fundamentals of coding and the fundamentals of things, because you really start to become a hacker at that point, and you start to a hacker doesn't know everything. A hacker has to search and comb through Stack Overflow for maybe people that have solved previous problems like this, or so I think it becomes that journey of trying to solve that problem takes you in a bunch of different directions, and you'll learn a bunch of things along the way. So I think that's probably the best advice I would have given myself earlier on. And I kind of learned that like the hard way. I kind of took a bunch of classes and got pretty proficient at things, but really only when I started to really become a hacker, so to speak, did I actually start to truly learn things. I don't have a PhD in machine learning. I have an MBA. I have a bachelor's in electrical engineering. So I didn't really learn the fundamentals in university. I was self-taught as well. So that's the best advice I think I can give you guys.
Yeah, I totally agree with you, Joe. So one thing I was getting at with this internship thing is to basically learning by doing. So in addition to classes, I would encourage everyone to either start open source projects from scratch or contribute to existing ones. Yeah.
Yep. Absolutely. That becomes your street cred in the space. So just to let you know, we do recruit people who contribute to PyTorch, and some of our folks, like we have a gentleman in Paris who joined us last year named Francisco Massa, and he's leading kind of external engagements in universities and that, and he was one of the PyTorch contributors. He worked on Torch Vision and a few other things around the project, and like really your street cred, like open source is a great street cred for anyone. Like so contributing, starting new projects, it gives you a lot of confidence, because frankly, we look at interviews are interviews, but then like really the proof is in the pudding in the code that you produce and how you collaborate in that community. So those are the two things we really look for.
That is fantastic advice. And it segues perfectly to a question that was submitted in the chat at one point about contributing to open source projects. You mentioned a few open source orgs on GitHub earlier, and someone asked if you have any specific open source machine translation projects that you would encourage people to contribute to.
Sure. I would try to advertise PyTorch as much as possible. I actually reply on the chat. So there are two. There are actually three three important PyTorch translation projects. One is called Fairseek. One is called Translate, the one we actually developed, and this one which is called OpenNMT, which is developed by Harvard and Sistran in Paris. There are many. I'm sure there are many more. Actually, translation and sequence-to-sequence models are actually a very hot topic. So I'm sure you can find just by searching many translation projects. But I would recommend definitely those three to start with.
Yeah, real quick as a follow-on. So who like for folks that want to get started, we do actually tag some issues. I asked like our devs, our core devs, as well as like Francisco and others on our team to like tag issues in GitHub as kind of like starter issues. So if you want to like comb through there, if there's something of interest you want to work on, you can actually pick an issue and like, hey, I'll raise your hand. I'll go work on this. And it kind of gives you a kind of a pathway into working within the project to becoming a PyTorch contributor. So I would search the issues and look for the ones that are kind of tagged as starter issues, or like, ones that people can get started focusing on. And that's kind of a good way. And The nice thing about that is because it's tagged by someone, on our team, if there's help needed or questions or whatever, they'll be really responsive. So.
That's great. Thank you. Besides trying to design models that don't use much data, what do you do? How do you gather data when you do need it? And how do you approach gathering data in an ethical way?
Yeah, sure. So how do we gather data in an ethical way? So first of all, we can actually purchase data. So what is very important for our system is existing human translations. So what you need to be careful about is when you sample data that you want to send for professional translations, you have to do it in a clever way. You don't want if you do it basically you want to gather data that will be useful for training. So if you gather data that you already have, then that's not useful. If the distribution of the data you gather is full of uninteresting sentences that are just hyphen hyphen hyphen, these are not words, this is also not good. So you have to be careful when you sample data. You have to be careful before sending it for professional translation. And another thing that we are actually doing is relying on unsupervised or semi-supervised techniques. So one thing that's very important is to you can work on open source with open source data, such as with things such as Common Crawl, and which has a lot of monolingual data. Another very important thing that we're doing is comparable corpora mining. So comparable corpora a strong suspicion that these are translation of each other. So as an example, you can take, the Wikipedia article of Michael Jackson in English and then Spanish. And then you apply some algorithms to extract some useful data from that. So these are various things that we do with data, essentially.
Great. I'm going to squeeze in one more question before we wrap up. And I think both of you have touched a lot on kind of important skills and things that you use on a day-to-day basis and that you find really valuable. But just to kind of wrap things up at a high level, what do you suggest, what skills do you suggest people build for developing a strong foundation in deep learning fields?
I mean, I can start from the product perspective. I mean, I think, there's I mentioned this earlier, there's kind of the fundamentals of product management that, if you interview at Facebook for product management, they will grow you pretty hard around, things like, your problem solving skills, your metrics, and kind of how you define metrics, for impact. I would say again, from a product management perspective, like having domain expertise in an area is actually even more beneficial in some ways. Like some of the PMs that I have on my team, are kind of previous researchers. So like Mahalia Miller, who joined us from DeepMind last year, like she was a former researcher in computer vision. So so I think having that deep knowledge of the space. But having the product manager mentality, someone who is unrelenting, someone who runs through walls, can move an organization, move an ecosystem, is collaborative. These are the kind of things from a product management standpoint really matter. But having that kind of base knowledge, I would say, like for me, it's like open source. Coming into Facebook, I was an open source guy. I was a framework, a tools guy. So like for me, that was like where they wanted someone to have that knowledge. So really, there's two pieces from PM perspective: the knowledge and the area that you want to focus on, and then really the skills, to own a product, to measure success, to drive the strategy, to be able to effectively communicate, with anyone from Juan's level, at the research scientist level, all the way through to like Shrep and our CTO or VPs. So there's a different level of abstraction you would speak with them at. So that's the PM perspective.
Yeah, I can maybe add another perspective. So to build a strong foundation on deep learning, I think that was the question. Maybe we start with maybe an introduction, like the course by Andrew on deeplearning.ai. But then go a little bit deeper by building foundation on linear algebra and things like that, and then go deeper by reading. Actually, you can go and read a textbook. So there are many of them, but maybe I can recommend maybe the deep learning textbook by Yoshua Bengio and others. There's another actually free PDF book which is going into the math from it's actually a professor in Germany in TU. Berlin University. He's from Mexico, but he's a professor in Germany, so there's a free PDF book there. And of course, you can also go from there to more recent papers. So I would encourage to read conference proceedings. So you can read the NeurIPS conference proceedings, you can read the ICLR conference proceedings. If you're more into, or ICML, or if you're more into natural language processing, like I am, you can go to ACL, EMNLP, and other conference proceedings. So maybe an intro and then textbooks, and then end up with actual academic papers for the latest, greatest research.
Wonderful. Thank you both so much. I apologize for keeping everyone over by a couple minutes. But Joe, Juan, thank you so much for your time, for being here today, for answering all of these questions. It's a lot to have thrown at you over the course of an hour, but you provided really amazing insight. I'll definitely be following up with both of you to get some of the lists of the resources that you recommended. And for everyone joining today, we'll make sure that those are posted in Slack for you to review. But thank you for your time. Thank you for joining. It was amazing hearing from you. And yeah, your advice is undoubtedly going to be very valuable to lots of people as they pursue their careers and their passions in this field. So thank you very much.
Thank you so much for the invitation.
Thank you. Yes, this is great. Great questions.
Yeah, inspiring questions. Thank you.
Thank you so much. Bye, everyone. Have a great day.
Cheers. Bye-bye.
Bye.